Alright, in this video we're going to be working Algebra 2 Homework 1.3, so we're just going to be practicing more stuff with lines and linear equations and linear functions. So we're going to write an equation in slope-intercept form that passes through the given point and is parallel to the graph of the given line. Well, that just means we have to, okay, we got a point, we need to decode this for slope, and then we'll have, then we'll write it in point slope, distribute to get to slope-intercept, okay? So I've got a point, I'm going to find the slope by kind of just working this thing around, solving for y. So I'm going to start by subtracting 5x from both sides, and then dividing everything by -4. Okay, so that means that I now know that the slope of the line I'm trying to write is going to be equal, because we're looking at parallel, so it'll be 5/4, right? Positive 5 over positive 4. So I've got my point. I've got a slope. It's going to be 5/4, and that means that the point slope equation is going to be y minus the y coordinate is equal to the slope multiplied by x minus the x coordinate. Okay, but it said write an equation in slope-intercept form, so we're going to need to distribute over the 5/4, and so I'll say y minus 1 is 5/4 x. If I multiply 5/4 by -3, well, 5/4 times 3 over 1, that's 15/4. Okay, so I've got minus 15 over 4. Okay, now if I'm going to try to solve for y, I need to add 1 to both sides. But in order to add with this, I need to think about adding 4/4 to both sides. So y is going to equal 5/4 x, negative 15/4, and you add back 4 of them, you'll have negative 11/4. Okay, and that's an equation in slope-intercept form. Okay. The second one, they gave me a point. We can find the slope of this thing going the same way. Okay, 3y equals negative 9x plus 8. Okay. And now I'm going to divide everything by 3. Y equals negative 3x. Got to be fair, got to divide everything. So that'll be 8/3. And let's see. Okay, so I know that the slope needs to be negative 3. I've got a point, so I've got my point. I've got my slope. It's my equation in point slope form is going to be y minus the y coordinate equals the slope times x minus the x coordinate. And then I'm going to distribute the slope, right? Negative 3x minus 3. And then I'm going to solve for y by subtracting 4 from both sides. Okay. And that was good. Okay, the next two are very similar. We're going to write an equation in slope-intercept form for a line that passes through the given point and is perpendicular to the graph of the given line. Okay, so we're going to do the same thing. We're going to work to find the slope. It's just we won't directly copy because that, equal slopes is for parallel lines. We're going to, make a negative reciprocal to get a perpendicular slope. We'll get there in a second. All right, so I'm going to just go over here and work on number 3. Okay. Go up here and leave myself some more room. So 3y equals negative 4x minus 6. Okay. I'm going to divide everything by 3. And I'll get y equals negative 4/3 x minus 2. Okay, I'm going to divide everything by 3. Now at this point, slope. Okay, got a point. Okay. Now the slope, it needs to be perpendicular to a line that has slope negative 4/3. So I flip it, that would be negative 3/4, make it negative, that's positive 3/4. So the equation here is y minus the y coordinate is equal to the slope times x minus the x coordinate. Okay, great. And just checking to make sure everything's right. Oh, nope, slope-intercept form. I got to distribute it. So that's going to be 3/4 of x. And if I take 3/4 and I multiply by 2 over 1, well, I'd have 6 over 4. I might just leave it like that. That's fine in this class. So minus 6 over 4. and then we're going to add 1 to both sides of this equation, and that would be like adding 4/4, right? And so then we would have y is equal to 3/4 x. Negative 6/4 plus 4/4 would be negative 2/4, which we could write as negative 1/2. Or, you know, in my class, we aren't called to simplify fractions. This is not an arithmetic class, right? When it wants you to simplify fully, it will say fully simplify your answer in the directions, like in the statement of the problem, right? We're not saying that we'd be just fine with negative 2/4 there too. But you do need to be able to simplify it, say for like the multiple choice section of your upcoming unit test, right? You need to be able to do that. All right, so over here, I'm going to start solving for y to try to figure out what the slope's supposed to be. Negative 2y equals negative 3x minus 7. Then I'm going to divide by negative 2. Right? Negative 3 divided by negative 2 is positive 3/2. And then I'll divide negative 7 by negative 2, and I will get 7/2. Okay, so I've got my point right here. And I know that the slope needs to be perpendicular to a line with slope 3/2. So I'm going to flip it and make it negative. Okay, so my equation is going to be y minus the y coordinate is the slope times x minus the x coordinate. Right, since it was x minus negative 1, just said x plus 1. And then I'm going to distribute the negative 2/3. Just like I've done in the previous 3 examples. And then I'm going to add 1 to both sides, which is going to be adding 3/3. And so if I have 3/3 minus 2/3, that's just 1/3. And so now I have y equals negative 2/3 x plus 1/3. And, well, that'll do. Okay. Now we're going to give an interpretation for the slope and y-intercept of the line that models the scenario. Okay. If appropriate, I might even throw in the X-Intercept, just for something different, because I haven't had that many opportunities to talk to you about the interpretations of these things. All right, so let's start with slope. I don't know. I'm not sure what's going to be the best place to start. Let's just start slope. Okay. Slope is the rate of change of y with respect to x. So it's the rate of change in the value of car with respect to the amount of time of its age. Okay. You could think about the slope is negative 1,478 units of y divided by units of x. Negative $1,478 per year. Okay, it's losing $1,478 of value each year. So we say that the car depreciates $1,478 per year. Okay. The y-intercept, well, remember that's where x equals 0. So if its age in years is 0, then I accept, okay, so the $13,906 must have been the price of the car when it was new. It must be an old car. Okay, so value of car when new, I might say. Or at age 0 years or whatever. Starting value of the car. I told you earlier that that was oftentimes the meaning of the y-intercept was the starting value. Okay, this one I can see a meaning for the x-intercept, so this is not a problem that was asked on the homework, but I'm still going to tell you what the answer is. Okay, but I'll work it in pink. Okay, the x-intercept, well, that's where y is equal to 0. So the value of the car goes 0 after some number of years, right? Now, that's probably not realistic, right? This is not the most realistic model of car depreciation, because you can see even after 10 years, there would be 14,780. This would be a negative number. Okay? Not anymore, but the car I used to drive was well more than 10 years old, and it was worth more than nothing, right, once its time was up. Okay, the x-intercept, it's going to be how long or when we expect the car to be worth nothing. Then over here, the real estate section of a local newspaper listed the selling price, which is represented by Y, along with the square feet, which is represented by X, for houses that are for sale in the area. The data were approximately linear, and the line of best fit had the equation Y equals 310X plus 208,000. We're just going to assume it's perfectly linear, because I'm not going to say it's like, you know, on average we increase 1 square foot. No, we're not going to do that. Right, the slope is, okay, it's positive 310 multiplied by the number of square feet. So for each square foot you add, that's going to increase the value by $310. Square foot, not very much. So you could also think about it, selling price, dollars per square foot. That's another way, you know, like the price per square foot. So maybe I'll write it like that. That's something you hear about, you know, when talking about real estate. So price per square foot. Okay. The Y-intercept. Okay. Well, that's going to be when X is 0. When the square feet is 0, well, maybe an empty lot, it's not free. You know, it's still worth something. So I might say price of empty lot, or price with 0 square foot house on it. Whatever you want to say. Okay. Now I'm going to just point out that in this situation, if we were to try to solve for the X-intercept would come back negative. And, well, a negative number of square feet, it just doesn't make sense. And so the X-intercept, it doesn't have any meaning in this context. So I think that's good. You know, like this one, it did have meaning. This one, it didn't. Okay. Harder to say. Y-intercept always almost has meaning in terms of like some sort of starting value. Let's move on to the next page. Oh, yeah, I like this problem. I found this one somewhere on the internet. So Carl and Ray compete in a 100-meter dash. Carl's distance from the starting line after the start of the race can be modeled by Y equals 10.7x. Ray's equation is Y equals 8.1x plus 10. And we've got both of these equations graphed in the window over here. But I'm just going to point out, okay, Y equals 10.7x, that's Carl. It's going to be this one because it goes through the origin, right? And then Carl ends up passing him by and ends up finishing the race ahead. All right, so I'm just going to call that one Carl and this one Ray. Okay, what do the slopes of the two lines tell you about the runners? Well, let's talk about the units of the slope of the two lines. Okay. The units is meters, units of Y, divided by units of X, seconds. Meters per second. Okay, it's like a speed, right? How much time, or how much distance are we covering each second? Okay, so speed of the runner. Moreover, I could be more specific. I could say Carl is running 10.7 meters per second, and Ray is running 8.1 meters per second. Okay. And what do the Y-intercepts of the two lines tell you about the two runners? That's what I was about to say. I was like, you know, that plus 10, means they're starting in different places. I think to, you know, bring this into like the context of the race or whatever, looks like Ray had a head start. So that's what I'm going to say. But I can quantify it. Ray had a 10-meter head start. And it does appear that he still lost, okay, based on that. So the 10-meter head start was not enough to overcome this sort of difference in speed. That looks like pretty major. Okay, Carl and Ray's friend Joe watches them race from the finish line. This is a question I added myself. Okay, write an equation for Joe's distance from the starting line during the 10-second race. Okay, well, he just sat there the whole time, I think. And so, I lost my pen. Over here. Yeah, there we go. So it looks like this is going to think that 100 meters is that. Okay, that's Joe. Well, Joe's equation, it doesn't matter what time it is, how long since they started racing. Joe's standing still at the finish line, so it's always 100. So I'm just going to say y equals 100, because that's his distance from the starting line the whole time. Okay. Now, let's see, how many problems do I have left? 'Cause, yeah, I don't think I'm going to be able to finish all of the problems in the amount of time I'm going to be able to record. So I think I'm going to record just the rest of this page, and then the second page, this will have to come as a separate video, and I will definitely link that at the end of this video, so it's something you can click on. All right, so suppose L is the line in the xy plane that passes through the points 4, 0, and negative 3, 3. This is perpendicular to L. What's the value of A? Okay, well, the slope of L is going to be 3 minus 0, y2 minus y1 over x2 minus x0, divided by negative 3 minus 4. Okay. So I need this line, I need it to have an equation of +7, or have a slope of +7/3. So I'm going to start solving for y. Divide by 5. Pardon me. Dividing by -5, right? But wait, that doesn't really matter. We need to just figure out the value of a, so that a divided by 5 is equal to not 3 over -7, but +7 over 3. Now I'm going to cross multiply. So I'll have 3 times a is equal to 5 times 7. And then a is going to be 35 over 3. And that'll be fine. Right? It's a perfectly acceptable number. So now we're going to write an equation for the line that passes through the point 1, 2 and is parallel to the y-axis. Right? It's a vertical line, so I know it's going to be an x equals. This point has x equals 1. I didn't go side to side, or at least no one's supposed to be. So that's going to also be x equals 1 on the x-axis. So I say that this is the set of all points where x is equal to 1. Okay. Now we're going to write an equation for the line that passes through the point -3, -4. Well, I could draw you a picture of that. -3, -4, and it's a horizontal line. Okay, well, horizontal line, that's when it's y equals, or you could kind of label this point and be like, okay, on the y-axis, it's y equals -4. These have what they have in common is their y coordinates, so that's the set of all points where y is equal to -4. I'm not going to have enough time to, like I said, I'm not going to have enough time to finish all of these problems. You definitely need to do the third page. It's very similar to a set of problems on the quiz, and I think also on the test or something. And so you should probably be able to see these on screen right now. Hope you make it all the way there, but if not, thanks for watching this one.